So today we will go through the topic of modeling and analysis of industrial structures using Staad Pro. So these industrial structures are also called as pre-engineering buildings. There's a reason behind why we call it as pre-engineering buildings, which I will be explaining you further. So today I'm going to cover these topics. So I'll be introducing you to the industrial structures and then explain you the features of the industrial structures and how they are built. And be going through the advantages of the industrial structures over the traditional forms of constructions like RC buildings and other forms of constructions. And then I will be giving you a brief introduction about the software tool Staad Pro. And I'll just walk you through how we can model an industrial structures. I already modeled the industrial structure, so I'll be going through that model to you. So yeah, the next will be how to apply the loads on the buildings and all the other stuffs in modeling and analysis of industrial structures. And then I will pick up a typical example and explain you how these PV structures can be modeled through Staad Pro. And finally, I will just give you a brief about how the industrial structures have evolved till now and the career opportunities for you guys taking this further. So basically, to start with, we'll just have a look, understand what industrial structures are. The question like structures that serves the specific function of an industry or support house equipments, essential raw materials required for the industry. Industrial structures are built over to serve the specific function for that industry. So either if you take a cold storage, then you need to have a certain infrastructure inside a building so that you can store the raw materials or the vegetables or the fruits or whatever, the pharmaceuticals, anything. So you need some basic infrastructure inside these buildings. So likewise in automobiles as well. So if you have body making inside the industry, then you need to have certain infrastructures for that. So any building which serves these purposes are called as industrial structures. So in the next slide, if you can see, the top image is a empty industrial structure, how it looks inside. So it's a huge, it's a vast, very wide area. And then in the second picture, you can see there are some industrial equipments or industrial machineries kept over there. And the movements for these movements inside the building will be easy for this kind of infrastructure. And you can see some girders over here. So these are used for the movement of the cranes. So shifting a material from one place to other place within the building can be possible by these kind of structures. So what are the salient features of these structures? So these structures can be a simple warehouse, a very small warehouse, to the highly sophisticated structures where you can even build a car or car body, or even you have designed for industry like Toyota in Bangalore. And then even I have designed these structures for microchips as well, the manufacture of microchips, pharmaceutical industry, the chemical labs as well. So this can range. The range of the industrial structures is very vast. And these structures basically are very single story. There will be only single story building with the height around 5 meters. That may vary from 5 meters to 15 meters in height. So that depends upon again the requirement of that industry. Basically, they are single story, and very few on some requests can be done for double story structures. That's it. Not much, because there are some restrictions on these buildings, building restrictions. So, and these can be of only steel structure, or it can be built as a reinforced concrete structure, part of it by a reinforced concrete and part of it as a steel construction. You can have both kind of things as per the requirement. Basically the walls, I will show you in the next slide how it will be, or you can just go back to the previous slide and you can see here, these walls are built of RC and these columns are all of steel. So, and we have a steel roofing as well here. So this can be a combination of these. And here the basic requirement will be like the foundations will be coming up to, foundations will be of RC and even the pedestals. And then further the steel construction will be taken up. And then the roofing system will be truss, which might be a single PEP rafter, or you'll have a traditional strut and tie model as well. I will show the pictures of those even in the further slides. So just now you can see there, here is a single rafter. Everything, the purlins are resting on this single rafter. So you can have this wide space inside without any columns in between. You can see here, this is the outer view of an industrial structure. You might have probably seen these kind of structures around the cities, wherever you live, even in the small towns. Nowadays, this is very popular. So basically, this will be the finished structure. Here you can see here there is a RC wall, and this is completely a steel cladding, and you will be having glass facades over here. And you can even have a small offices inside these industrial structures for your requirements. And then you have this complete industrial building where the manufacturing and other process of industries take place. So this will be the initial stage, how it looks when you start doing it. So these are the columns, rafter, and intermediate columns. So what will be the advantages of this kind of a structure? So the basic advantage of this kind of structures is the construction time. So PV structures can be constructed 40% faster than any traditional form of construction, say RC. Even if people from the civil engineering will might be aware of MIVAN kind of a construction, or the tunnel kind of constructions, where they say that the RC construction will be very faster. If you compare to that kind of structures as well, this PV structures can be constructed very faster. I have been working on these industrial structures, and I have constructed the PV structures within the span of 15 days for around 3,000 to 5,000 square feet of area. So that fast you can construct these PV structures, which will help faster occupancy of the industries, and they start manufacturing or whatever the industry serves for. And these are lower cost, and technically speaking, PV structures are all made in factories. So we actually manufacture the sections for these PV structures in factory according to the need of the design. So there's lot of saving in the materials, lot of saving in manufacturing, and even the construction joints, or you say connections and all. So we save a lot of materials over there. That is achieved for the optimal design of the structural components. And then the major advantage of this industrial structure is you have a large clear span without any columns intermediate. So if you take any industries, so they require a large space inside without any obstructions for their goods moving or their materials moving inside the buildings. So that can be achieved in these industrial structures, which is not possible with any kind of other traditional forms of construction. So there you can, this 90-meter clear span is very general. I mean, we have almost achieved the 150-meter clear span as well in certain kind of constructions. And then flexibility of expansion. So PV structures can be expanded in both the ways very easily as per your requirements. So say for example, you have started the industry for certain space, and then you have a free space available as well, and you need to expand. So that's very easy in these kind of structures. I will demonstrate with a model further this expansion, how you can do the expansion in PV structures. And then the quality control. So since all the sections are manufactured in factories, so you have a lot of hold in maintaining the quality of this construction. So the materials you use, you can control it. And this is not just like inside you just mix the concrete, and then you might not get the proper grade of concrete when you are doing the traditional kinds of construction. Here it's all factory made, so you have good control over the quality of these materials. Now Staad Pro. So Staad Pro has been widely used all over the world, particularly for the steel design. Staad Pro is vastly used. So this is very popular structural engineering software. You can model 2D, 3D models in this software, and it allows you the multi-material design and analysis in different analysis in a single program. It has very user-friendly tools, and you can do a lot of static and dynamic analysis of structures as well. in Staad Pro. So the steps involved in modeling and analysis of a PV structures using Staad Pro will be like divided into four. Like you first generate the model, then you verify the model, then you go on for the analysis. So for model generation, you have very easy tools in Staad Pro. You can easily replicate the repetitive geometry in this, and then you can even import the AutoCAD files into the Staad Pro and build the model from the plan of the AutoCAD drawings. And then for model verification, you can view the model in all full 3D shapes. This I can well demonstrate the model verification through taking you through this Staad Pro model. Let me show you the model we have already developed. So this is one of the models we have already developed. This is a storage. This is one of the storage unit we have designed previously for a organization. So model verification can be done like this. See, you can have a 3D view of this model like this. So you can verify the model if you have done it properly on Staad Pro. So different kinds of types of analysis is available in Staad Pro. So you can have a 2D analysis, 3D analysis. Basically, the matrix method is used in analysis in Staad Pro. For foundations and plate designs, you also have the FE analysis in Staad Pro. And then seismic analysis, you already have a built-in features in Staad Pro for seismic response spectrum analysis and time history analysis. And you have a harmonic load generation module also in Staad Pro for seismic analysis. And further, you can have a wind load generation. It has already got built-in wind definitions in Staad Pro. That will be very easy for carrying out the secondary analysis. And you can even calculate the displacements, forces, moments inside a particular structural component. And moving load generation for the crane loads is also possible through Staad Pro. So this is the basic information for that model. So we have this 12.2 meter span, wide span here, and then we have another small span of 3.93 meters, both side by side. So the offset distance in this direction will be like 6 meters wide. So you have these bays, all the 6 meters, two bays of 6 meters, and the column size is tapered. We have this tapered because when we design these PV structures, so we follow the pattern of the bending moment diagram for the particular bending moment behavior of that beam or structural member. So we shape that sides in tapered manner so that it will help you to reduce the cost of the material and optimize the design. So let's go through this Staad Pro. So when you open Staad Pro tool, this is how it looks. I'm using Staad Pro V8i, but you have a latest version of Staad Pro as well available in the market. So this is the bulk storage. I have already made the modeling. So this is the model I have carried out for sake of simplicity of explanation. I've already done this. So you have a lot of tools here. You can see this. These are all new structure tools, and these are all the viewports you have here. Different viewports. This is the front, and this is the isometric view. So this is the view from one angle, and the top views, the bottom view, side views. So a lot of viewports are available here, and even the modeling is very easy. Staad Pro. So basically, you can see here, I've already modeled for the given information. So this is 12.2 meters wide span, and here it's 3.93 meters. And then this will be the Staad Pro screen. When you open the Staad Pro new file, this will be the screen. So you have to create a new project here. So for the sake of simplicity, I have already created a model here. So I'll be sharing that model screen. So this is the model I have already created. So you can see here, this is the span, the 12.2 meter wide span, and this is the smaller span, 3.93 meters. So in the Z direction, you can see there is a bay of 6.235 meter wide. So I have already created this model. So the height of this model is 8.31. This can be created through a geometry. You have a geometry screen. So if you see here, so you have this whole process dropping down in Staad Pro, and that's very easy to catch up with modeling and analysis. So first thing is setup is just you give the job information, the client information, and the name of the engineer, the approver, and the date. So it's just general information here in the setup. And then when you come to the geometry, you have wide tools here to start with the geometry. So keeping this apart, I'll just give you a simple demonstration how you can create a pay in a Staad Pro. So all you have to do is you have to create a node here. So I'll just create a node here after 25 meters. So I have created a node here, and then I will take this node and just translate it in this direction. So we have this translation repeat command. So here you can give the spacing for that and translate that node. In the same way, you can just translate it in the y direction. It's so simple. So now this is just I have made up 4 nodes, and if you want to build a structure like this, you just connect this with these beams and your line diagram is ready. So based on this tool, I have created this model here. So this is how you create a model very briefly in Staad Pro. So you have a geometry, and you have these options called beam. If you want to have a line diagram, you can use this beam. And then if you have a plate modeling, then you can use this plate. And similarly, there are a lot of options available. And then in general, if you come to general, you have this all information about the property of the material and the specifications when you have to release or give the fixity or movements to be released in the members. That's kind of specifications you can give here. So I have already created this tapered model. You can see here, this is a user defined taper models. I have defined a tapered section here as I showed you in the presentation. You have the column size of 615 250 by 5 mm. So I've given these all properties, and you can see the material properties as steel. So you can even edit these properties here. You can give this according to your requirements and create a new property. And here for the material properties, you can specify the materials, and then even you can change the properties of these materials by giving the values here. So if you have high density steel and low density steel, you can specify those properties here and create a model. So then you have a support information. You can give the supports, like the fixed supports or the hinge support. And then you have this loads and definition. This is the major part where you apply the loads. So as you can see here in the definitions column, you have all the definitions pre-built. So you have vehicle definitions, time history analysis for seismic analysis, and wind definitions. If you add the wind definition, you can just see different loads and actions. You can just give the information regarding the height. So if you go through 875, IS 875, it's a code for wind loads. So there you can see what are the loads. I mean, there are some factors called K1, K2. So you can enter those here, and the Staad Pro program will automatically apply the required intensity of wind into your model. Or you can just calculate. Staad Pro is a US based tool, so they have ready-made tools. They have ready-made definitions for US. So if you just click on add as per ASCE, then you can see if you specify these all categories, it will automatically apply. So this is the very handy tool for defining the winds in Staad Pro. Or you can still define those wind definitions manually. I have done it manually here for the sake of your understanding. And the seismic definitions here, I have already defined the seismic definitions here. So I have, as you have different codes here as well. So I have chosen IS code, and then I have entered the zone factors as per my requirements, and Staad Pro will automatically generate you the seismic definitions for this particular model. And coming back here, the load case details, you can see the seismic is a load case, and then I just add this direction of the application of the load here. so that the program will automatically calculate the seismic definitions. And then you have a dead load. I have added a dead load here. The self weight of the material will be automatically taken by the program, and you give this material density and material properties. And then I have calculated this anticipated loading on my frames and have applied it here. So as the blue highlighted will show you what are the applied loads here. So this has been calculated as per IS 875, and then this is the collateral load. The collateral load is nothing but the loads which we use inside the buildings as per the requirements. Say for example, there are light hangings or some chains hanging on from the top, um, or there are some crane movements and the dead weight of the crane. So these all are the collateral loads. So you can add them on these structures. And then the live load will be the codal defined. So I have calculated and applied it on this structure. Then we have wind pressure. So I said you have applied the wind manually. I have calculated it manually and have applied on the structures. So wind becomes very prominent when we have these open structures because the wind gust might push your structure upwards, and the since these PV structures are all connection based. I mean, pedestal is of concrete, but the columns are all connected through bolts and nuts in the bottom here. So this wind is a prominent load which acts on the PV structure. So it might uproot the structure completely if you don't take care of the wind here. So wind analysis is very important in PV structures. So I have applied these all loads here, and then I have made these load combinations as per IS codes, 25 load combinations including seismic. So these are all the load combinations I am taking care of. And then after this load definitions, we will have the analysis part. So structure is analysis for this given parameters. So after analysis, you have the results of the analysis, and then you can see whether the structures are how the structure behaves. I mean, this is how this complete modeling and analysis takes place in the Staad Pro. So coming back to our presentation here. So this was the line model you saw there, and this is how it looks in 3D. So you can verify your model here. Any changes are there, or if you have made something different properties, you have assigned different section properties anywhere, you can just make sure your model is it right or wrong by this kind of views available in Staad Pro. And coming back to this evolution of this field, I mean, so basically you would have seen a lot of traditional buildings around you, but the industrial structures have picked up a lot in last 10 years. You know, there have been lot of changes in the kind of buildings they have constructed here, because basically when we if you look back and see your village construction, there will be like an RC kind of a brick walls, and then over that it will be a roof, and then it's very traditional. And now evolution of these steel structures has changed a lot of perspective in the market. So it has rapidly changed. These structures can be built according to your requirement. I mean, all the aesthetic properties are also taken care of in these structures. So the steel is a unique material where you can blend, you can mold it to whatever the forms you require. So that gives you the flexibility of the architectural views, whatever you require. And then this is very natural, and it blends very good with wood and glass. You would have seen a lot of buildings around you with the glass decading and steel structures, only glass and steel. That gives a very pleasant view, and this kind of structures is very possible by steel. And flexibility, I mean, you can find your structures in both directions according to their requirements. So that gives you uh, very much flexibility in construction, as per the requirement of industries. And then career opportunities, if you talk about, so this is very budding. I mean, most of the people are still stuck with this traditional RC kind of construction, but this is a very new thing. So this is a budding technology, and most of the people are now exploring this opportunity. This is used very much, and there is a lot of scope in design of PV structures. So most of the conventional buildings are also nowadays has been replaced by PV structures. The most important thing about this PV structure is you have this flexibility of constructing these structural components as per your requirement. You can take any shape. You can save a lot of things in materials. So that gives you a lot of free space or a lot of things to experiment on. Major advantage of this PV structure is like large column free space, and most of the industries and most of the buildings require that nowadays. So that's possible, and that's not at all possible in your RC kind of a structure construct. And applications of PV is huge. I mean, you take any kind of a building, you need PV structure. So nowadays it is used in factories, warehouses, even in offices. Even the offices are built by PV. You have seen around many gas stations which are of PV structures. Even the showrooms, new showrooms, metro stations, even school indoor stadiums are built of PV structures. So there's a lot of things PV can be done. So you have a good opportunities when you consider designing the PV structures. So that's it, guys.